Hello everyone. Today we're going to be going over the conditional probability. So here we have some examples. Uh, we have we have a new bill proposed in government. There are 1,456 people who will vote on it. They either favor the bill or oppose it. They might also be broken up into whether they are male or female. So for part A, we have what is the probability that a person favors the bill and it is male. So we can see here that they favors the bills right here and they are male is 392 out of 1,456. So this would be 392 over 1,456, which is equal to 0.269. Part B is saying what is the probability that the bill is just favored in general? So we can just see this by the row of by the row favor. We can see that it's 1041 over 1,456. So this is 1041 over 1456, which is equal to approximately 0.715. C is saying what is the probability that the bill is favored given that the person is male? So we can see here that we're just looking at the male side. So we know that it is 392, which is favored, and over 633. 392 over 633, which is approximately around 0.619. Alright, so here we have more examples where we have D is saying, what is the probability that the bill is favored given that the person is female? So we can just look at the female column right here, which is, we see that 649 females favorite out of 823. So 649 out of 823, which is approximately around 0.789. Now the next one is saying, what is the probability that a person is male? And the next one is saying if they are female. So we can see that the males are a total of 633 out of 1,456. So the probability of male, I'll just put M for male, is equal to 633 over 1456. Now we can go on to the probability of female, which is same thing right here, 823 out of 1,456. We have this conditional probability where this is saying the probability of B given A. So here we can see that the probability of B is what we are looking for. This line right here indicates given. What are we given? A. A is the event that happened first. So this is what conditional probability is. We can also see that the probability of B given A is equal to the probability of A and B over the probability of A. Whatever your given is over here would be the probability of that given in the denominator right here. So if I had probability of A given B, the numerator would be the same thing and the denominator would just be probability of B. This would be the conditional statement right here. Conditional probability and the conditional statement, we can move on with this example right here. So it says we have a new bill proposed in the government that there are 1,456 people who will vote on it. They either favor the bill or oppose it. They may also be broken up into whether they are male or female. So the first question is asking, what is the probability that the bill is favored given that the person is a male? So we can see that we can use the conditional probability here, where we have the probability of favored. I'm going to abbreviate that, given that they are male for M right there. So we can see that this is the probability of favored and male over the probability of male. So the numerator is favored and male. What is the probability of favored and male? So favored and male is 392 over 1456, and then the denominator is probability of a male, which is 633 over 1456. Now we can see that these cancel out right over here, just leaving us off with 392 over 633. Now we can move on to part B, is what is the probability that the bill is favored given that the person is female? Okay, so now we can see that this is the probability of favored given that they are a female. This is basically saying is equal to probability of favored and female over the probability of female. So we can see that who is favored in female, we can see that it's 649 out of 1456. So we can write 649 over 1456 right there. And the denominator is probability of F, which is 823 over 1, 4, 5, and 6. We can cancel these out, and we're just left off with 649 over 823. Now we can move on to example 18. We're saying a bowl contains 7 blue chips and 3 red chips. 2 chips are to be drawn successfully at random. Keyword right here, without replacement. So for the first one, we see find the probability that the first draw results in a red chip and the second draw results in a blue chip. So we can label this, the first one, as A, which would be the first draw, which is the red, and then B, which would be our blue chip. Okay, our blue chip, which is our second draw. So it says the first draw is the red chip, so that's the probability of A, which is how much? 3 red chips out of 3 plus 7 is 10, so that's 3 out of 10 chance of getting the red chip. And then the second draw results in a blue chip. So we are given that it's a blue chip, so this is the probability of B given A. This would be our, we know the denominator would be 9 because without replacement, when we take the first draw, we would not drop it in the jar. So the denominator would be 9. And second would be the blue chip, and we know that there are 7. So now we can go ahead and solve this, which is the probability of A and B is equal to the probability of A times the probability of B given A. which is equal to 3 out of 10 times 7 out of 9. Can simplify this. This would be 1, this would be 3, and we're left off with 7 over 30. Now this is called the multiplication rule. This is basically the same thing as the conditional probability, where we have the probability of B given A is equal to the probability of A and B all over the denominator of probability of A. If you cross multiply them, we would get pretty much this right here if we cross multiply. So this is called like the multiplication rule. So now we can move on to the second question saying find the probability of drawing a red chip on each of the two draws. So both draws would be the red chip. So first we can see that if we set A equal to the first red chip, and then B would just be our second red chip. Or better yet, we'll just use C, the second one. Now we would get, so the first draw would be probability of A, which would be 3 out of 10. And this is the probability of C given A, which would be, if we take 1 without replacement, it would be 2 over 9. Now we could just multiply this out. It would be the probability of A and C is equal to the probability of A times the probability of C given A, which is basically 3 over 10 times 2 over 9. We can simplify this to 3 and this to 1, giving us 2 over 30. We can simplify this even more, 1 over 15. So now we can move on to example 19. It says the probability that I eat vegan pizza this summer is 0.85. The probability that I visit Portland this summer is 0.92. And the probability that I eat vegan pizza given I go to Portland is 0.9. So here we have part A is asking what is the probability that I go to Portland and eat vegan pizza? So this is basically saying the probability that I go to Portland, which is Portland, we'll set that as P for Portland, and go eat vegan pizza. And we'll put vegan pizza as V. This is basically saying the probability of P times the probability of V given P for Portland. Now we know both of these actually. The probability of P, which is the probability that I go to Portland, is 0.92 over here. And probability of the eating vegan pizza, given that I go to Portland, which is right here, 0.90. We would just multiply these two and it would give us 0.828. Now we can move on to part B. Given that I ate vegan pizza, what is the probability I go to Portland? So straightforward, probability that I go to Portland given that I ate vegan pizza. It's one of conditional probabilities, so this is equal to P and V all over the probability of V. This is equal to the above portion is basically part A, and part A is 0.828 0.828 over the probability of vegan, which should be right over here, 0.85, and that is equal to 0.974.